no solution, how those look when you're solving algebraically versus graphing. Okay. First of all, so solving by graphing is great when you can easily tell where your lines would intersect, or when you can tell you have no solution or you have infinitely many. But if your, say, ordered pair where you're intersecting, if your x and or your y value is not an integer, it can be hard to tell exactly where they're intersecting. So algebraic methods are better to find exact solutions, although graphing, there are cases where graphing might be helpful if you already have a graph or something like that. But these are used to find exact solutions. So we're going to review the substitution method first. You do have to know how to do both methods. So I will ask you, like you can see in the directions for the first two examples, it does say to use substitution. So just make sure that you are following the directions, which one it's asking you to use when you're doing the practice or on a quiz or test, because your work is graded as part of that. So with substitution, you are substituting one equation into the other. So you want to make sure that one of your two equations you have solved for one of your variables x or y, and then you substitute that expression into the other equation to replace whichever variable you solved for. And then say you solved for x, once you find x, you can substitute that back into an equation to find your other variable y. So there's multiple substitutions happening. So if we look at example 1, just to review this, looking at the two equations, and it says to use substitution. So first determine which variable in either equation would be the easiest to solve for. So just by looking at that, which variable in which equation would you get by itself? X in which equation? The first one. So we always get in the habit of solving for y, and I would say always look for a variable that has a coefficient of 1 or -1 and get that one by itself, solve for that one, because you're going to have less of a chance of dealing with decimals or fractions and that sort of thing. So if I solve this top equation for x, that's step 1. So I would add 7y to both sides. I'm going to write this over here. So I would have x is equal to 7y plus 11, or 11 plus 7y. And that's step 1. I solve for a variable. So now I can take what x is equal to, the 7y plus 11, and substitute that in for x into my other equation. So make sure you're substituting it into the other equation, not the same equation that you just used to solve for x, and that you are replacing the variable that you solved for. So when I do that, I'll have 5 times, in place of x, the quantity 7y plus 11, and then plus 4y equals -23. So here's another way you can tell that your substitution is correct. You should only have one variable in your equation. So I only have y, because now I can solve that equation for y. So from here, to solve for y, simplify this left side. So I'll distribute the 5. So that would give me 35y plus 55. Then I still have plus 4y equals -23. And I would combine my like terms. So 35y and 4y, I have 39y plus 55 equals -23. And then solving for y, subtract 55. So 39y is equal to -78. And divide by 39. And I get y is equal to -2. Okay, so I have one of my two variables. You need to solve for both x and y. So then step 3 is to substitute this value back in to find x. And with substitution, it's often easiest if you just go back to this equation that you already solved for x and substitute it in there. And that way you don't have to substitute it in and resolve for x. So if y is -2, then I have x is equal to 7 times -2 plus 11. So I'm putting this back in up here. So that means x is -14 plus 11, so x is -3. So then my final answer, I'm still, even though I'm not graphing, I'm finding the ordered pair where these two lines would intersect on a graph. So my solution as an ordered pair is -3, -2. Questions there? Okay, why don't you go ahead and solve number 2 using substitution. Solve number 2, find the ordered pair where those two lines would intersect.
Good morning. Please excuse the interruption. All students with last names A through D that return the flu form can report to the comments at this time. Thank you.
Or are you still solving? Okay. we solve tracks, because we solve for x. So if you were solving for x, you'd have to divide everything by 62. So the variable has to be completely unknown, so just a coefficient of 1. So I see here, you solve for y first. Okay, because that's what I would solve for y. So you can immediately solve for it. You have to divide by 5. This would be, no, if you're dividing by 7.
Okay. Double check. It should be x is positive 4, y is negative 1. It does not matter which variable you solve for, either x or y in either equation. Again, I usually look for the variable that has a coefficient of 1 or negative 1, if there is one, because that's the easiest to solve for, but some of you did not solve for that one. You should still get the same answer as long as your work is all correct. Make sure, though, if say in the top equation you were deciding to solve for y, because that would result in having to divide everything by negative 3. Remember that if your decimals would be repeating decimals, you have to keep that as a fraction. Otherwise, it's not going to work out exactly. So if you are solving for a variable that does have a coefficient other than 1, just be aware of that you might have to keep things as a fraction if the decimal is not just a terminating exact decimal. Okay, but if you have questions on that as you're working on things, just let me know. Otherwise, we'll move on to the elimination method. This can also be called the linear combination method. So depending on how you're familiar with it from Algebra 1. But this is where you, just like the name suggests, you're trying to eliminate one of your variables by either adding or subtracting your two equations together. So you want to, in step 1, if you have to, multiply one or both of your equations by a number to result in two equations that contain opposite terms. So you're trying to eliminate x or y by getting their terms to be opposites. And then in step 2, it says to add the equations. You could also, in step 2, depending on what you have for step 1, you could subtract the two equations. But you're trying to eliminate a variable, solve the equation for the other variable, and then substitute that value back in to find the remaining variable. So in number 3, all of these were using the elimination method. In looking at this, so again, you can eliminate whichever variable you want to. There's not a wrong way to do it. I usually look for which variable is going to be the easiest to eliminate and contain the least amount of steps. So I would say in this one, if I look at the y's, both y's right now have a coefficient of -5. They're the same. I like to do what they suggest up here, and I like these to be opposites. So I would like one of them to be +5 so that I can add the equations. Just because sometimes with subtracting, you tend to not carry your subtraction all the way through. So what I would do is I would pick one of these two equations and multiply everything by -1 so that one of the y terms becomes a +5y. And then when I add them together, they'll cancel out. So I'm going to keep the top equation as is. And if I multiply everything in my bottom equation by -1, I'd have negative 4x and then plus 5y equals positive 12. And now I notice that if I add the equations together, the negative 5y and positive 5y gives me 0, so that's eliminated. So you don't have to write the 0 there, but the y's are eliminated. And then I add everything else, and I carry it through. Also notice, I should have said this at the beginning, for the elimination method, you do have to have all of your like terms and your equal signs all lined up. So sometimes it does require you to rearrange the equations if not everything's lined up first. So now if I add these, 6x plus negative 4x is 2x. The y's have been eliminated. I bring down my equal sign. Negative 8 plus 12 is 4. And I can now solve for x. So divide by 2, and the x would be 2. All right, and then from here, I just substitute the 2 back into either of my equations, and I usually substitute it back into one of the original, so not the one that I had multiplied by negative 1, and it doesn't matter which one I substitute it back into, so let's just say I substitute it into the top one. So I would have 6 times x is 2 minus 5y equals negative 8, and then I solve that equation for y. So that would give me 12 minus 5y equals negative 8. And if I subtract 12, I have negative 5y is equal to negative 20. And then divide by negative 5. So y is positive 4. And then my solution again is an ordered pair. So that would be 2, 4.
Students with last names E through K that filled out the school form, please put the comments at this time. Thank you.
Okay, any questions on that one? You could have, like I had mentioned, rather than multiplying by a negative 1, since they're the same, you could also eliminate them just by subtracting everything. I just tend to get them to be opposite so I can add them. That's just my preference. But if we look at 4, so in terms of looking at the x's or the y's, which variable would you choose to eliminate, and then what could you do to eliminate that variable? Carter? Which one are you eliminating? X or Y? X's? Okay. And then, so you could multiply by, what did you say? Negative 3. Yep, you could multiply by 3, and then they'd both be 6, so you'd have to subtract. Or if you do negative 3 and they're opposites, you can add the equations together. So that would give me a negative 6x and a 6x. So if I multiply everything by negative 3, negative 6x minus 9y equals negative 15. My bottom equation stays the same, 6x plus 9y equals positive 15. And now my goal was to eliminate the x's, which negative 6x and 6x do eliminate, but negative 9y and 9y also eliminate, and negative 15 and 15 also eliminate. So I end up with 0 equals 0. Anybody remember when you get this, what your solution set is? Or have an idea? So it's one of the two. It's either no solution or infinite. So what you look at when both of your variables eliminate like this, if you end up with an equation that's true, like 0 does equal 0, that's true, this then is infinitely many solutions or infinite solutions. I'm going to write infinitely many solutions. So when everything cancels, that means if you or basically, if I would have multiplied by 3, the two equations would have been the exact same. So if you were to get them in slope-intercept form to graph them, they're the same line. That's what that means if you get a true equation. If you got something false, like 0 equals 10 or something like that, that would then be no solution. That would imply that the lines are parallel. Okay, and then one last one together if we look at 5. So here we don't have x and y, we have a and b, same idea. if I were to eliminate A or B, which one would you say you'd look at this and eliminate, and then how could you do that? Any ideas? Isaac? Okay. So get them to both be 6. Why did you look at the B's versus the A's? Okay. Okay. And I would look at that too. It's definitely you're dealing with smaller numbers with the B's. I also would look at one of these is already a negative and one's already positive. So that's kind of nice too. I don't have to worry about multiplying by a negative since they're already opposite signs. So I'd want to multiply the top equation by 2 so that it would be negative 6b, and the bottom equation by 3 so that it would be positive 6b. So here's where you would have to multiply both either way. For either variable you try to eliminate, you have to multiply both equations by a different number. So multiplying my top equation by 2, I'd have 16a minus 6b equals negative 22. And my bottom equation by 3 is 15a plus 6b equals negative 9. And then my b's are opposites, negative 6b, positive 6b. So by adding them together, they're eliminated. And I can add everything else. So 16a and 15a would be 31a equals, and then negative 22 and negative 9 is negative 31. So divide by 31, and a is negative 1. And then again, I would go back to one of my 2 original equations to substitute it in. To solve for b, I'm going to pick the bottom one just because the b term is positive. But again, it doesn't matter. So I would have 5 times negative 1 plus 2b equals negative 3. So negative 5 plus 2b is negative 3. Add 5. 2b is equal to positive 2. And then divide by 2. So b is 1. And then still write your answer as an ordered pair. So when you have variables that aren't x and y, just keep in mind in an ordered pair, x comes before y, it's alphabetical order. Same thing applies here. So a is like your x, b is like your y. Keep it alphabetical. So I'd have negative 1, 1. Okay, so I'd like you to solve number 6 using elimination, and then also, I realize this is misnumbered, this should be number 7 here. But take a look at question 7 as well. So between the 2 methods, when would substitution be more helpful or easier to do versus when would elimination be more helpful or easier to do? So think about between the 2 methods, when would you look at something and say, well, I would definitely use substitution here versus I would use elimination for this one. So just think about that after you look at 6.
Students with last names L through P that turned in their flu form should report the comments at this time. Thank you.
We still look at that very last question. I will pass out the assignments as I come around too, so let me know if you have questions on 6. But keep your sheets out because we'll still talk about the last question. Bless you. Okay, it looks like we're all okay, at least for 6, getting no solution. So no matter which variable you ended up trying to cancel out, both would cancel out except the constants do not cancel out. So I had tried to eliminate x, but that is no solution. If you did put the empty set symbol, that's fine. You don't have to write the words no solution. And then just quickly, so if somebody would volunteer, when would you decide to substitution over elimination, or when would elimination be the easiest? So what are things you would look for? Well, I'll start here. What are things you would look for in your equations to say that substitution would be helpful or would be easier to do? Isaac? Okay, yeah, so substitution, if you already had a lone variable, a variable that's isolated, that could be more helpful than elimination. So I'll say substitution can be easier when there's already an isolated variable. And then think about when would elimination be the most helpful? What would you look for elimination, Braxton? Are equal, or I would even say opposite, so they would easily cancel. Yes, so elimination is, I'll say most helpful when one variable
Students with last names R through S that turned in their forms can report to the comments at the Thank you.
I'll say when one variable in both equations has the same or opposite coefficients. So substitution can be easier when there's already an isolated variable. Elimination is most helpful when one variable in both equations has the same or opposite coefficients. That way it can be easily eliminated. But like I said, on your assignment in the directions, I will ask you, because I want you to practice both. So it does ask you for the first 4 to use substitution. And then it asks you on the back side for 6 through 9 to use elimination. For questions 5 and 10, those are questions that require you to set up a system of equations. So you have to set up your 2 equations and then solve it. And whatever method you use to solve it is up to you. So for 5 and for 10, you can use substitution or elimination, but you actually have to set up the two equations first. Okay, I know we didn't go through one of those. We've gone through setting up an equation before, but we didn't go through setting up a system. I just wanted you to be able to try that. So if you have time to work on this, let me know if you have questions.